A lot of us have gotten into this mindset that the AI is always getting smarter. The AI is smarter than people and it gets smarter all the time. And that's not really how AI works. Attackers really are very good at using old technique in a new space. Now it's much easier to create a voice that sounds like somebody. It's much easier to create a video. We have to learn new ways to approach securing these systems. If you don't defend these systems, if you don't build them resiliently and securely, people will attack them and make them unfit for use for purpose.
Dinah is the Chief Information Security Officer at Protect AI and a global force in cybersecurity leadership with a career spanning Microsoft, IBM, Symantec, and KPMG. Dinah has spent decades shaping the security practices that safeguard both enterprise and emerging technologies. She's a keynote speaker, author, LinkedIn Learning instructor, and the voice behind Bright Talks, the Security Balancing Act. In this special feature, we explore what it really means to protect AI systems, the techniques in ML SecOps, and get a rare glimpse into what a day in the life of a CISO looks like when we're building trust and transparency in frontier tech. With the increased use of large language models for both offense and defense, what concrete steps should organizations take today to brace for AI-powered offensive tooling?
We're really going to have to fight AI with AI. Are your incident response plans AI ready?
Dinah Kelley, welcome to AI Cyber Magazine.
Thank you so much, Confidence. It's absolutely an honor to be here to speak with you.
Awesome. I've been looking forward to this for such a long time. But to help the audience really get to understand who I'm speaking to today, I wanted to share with us what formative experiences or influences best explain the Dinah Kelley we see today.
Yes, it's a great question. We sort of have to go way back in my life. When I was 9 years old, my father brought home a programmable calculator. And he showed it to me and my brother. And my brother's a few years older than I am. And my dad didn't make a distinction of like, oh, I was female and my brother was male. He just thought that the older child might be more interested. And I fell in love. I figured out how to code that calculator. And you got to go way back now because like it was not a thing to have programmable calculators. We're talking the 1970s. So I fell in love. And then later, again, through my father, because of his work at MIT Lincoln Labs, I was able to get on the DARPANET and be on the PDP 10s and 11s in the 70s, which were the precursor to what we know as the internet. And I just fell in love with connected computing and being able to manage systems. So that was really it. It was just this basic childhood wonder and interest in this very emergent technology. So when I had the opportunity to go to work, I went into editorial because I had been an English major. I didn't know computers would be a career.
Oh my God, you were an English major?
Yeah. And I didn't know computers could be a career. I eventually, folks realized I was always the go-to IT person. So eventually I switched over into IT and I worked my way up to being the manager at a startup in Cambridge, Massachusetts. And I had 9 offices around the globe. I was really proud of this network that I had created. We were able to do very cutting edge things for the time. It's now the early 90s. And then somebody got onto my network. Somebody attacked it. So I went from just loving systems and creating connection to realizing that if you don't defend these systems, if you don't build them resiliently and securely, that people will attack them and make them unfit for use for purpose. And that's what's driven me for the whole rest of my career is just, I want people to be connected and use technology. And that means I had to focus on security to allow them to use it safely. The other 2 big pivot points in my life that occurred and got me here to AI was first, I realized no matter what I did at layer 3 with my networking, that it was always layer 7. That was where the bad guys were getting in, it seemed. So at that point in my career, I pivoted to looking very closely at AppSec. This was before DevSecOps. We just called it Secure SDLC at the time, but I got really deep into that, covered that when I was at Burton Group leading the security risk management strategies program, and then also started working with large enterprises to help them bring security into their application security lifecycle. And now we all know this as DevSecOps, which I love. And then AI. I was at IBM. We were training Watson for cyber, and I realized that passion, that like flame of, oh, I need to learn about this, that happened all those years ago with the internet. It was happening again with AI. But also whatever we did at the network layer, even what we do at the app layer, it's different now in AI. So I really started focusing on research on how to understand how to secure the AI lifecycle, which is how I ended up, actually working on ML SecOps.
My goodness, your story is so inspiring, and there's so much to learn from there. From an English major to just coming back to having that sort of setback in your experience and
Yeah.
leaning on to what people typically were leaning forward to you for, and just drilling down there. And just the mention of the fact that you didn't think computers were a career, years ago. And I'm like, no, like this day and time, everyone wants to be here. So it just really shows a change in times and
Yeah.
how beautiful a journey technology has been. But now that you mentioned AI, I'd like you to give us some crash course on the difference between LLMs, ML, and AI. Because a lot of people use these terms interchangeably and sort of throw them around the place. So
Yeah.
if you were to give an analogy or use some way to make it simple for someone to distinguish between them, please share and just let us, have these three things separate.
Yes. When I explain it, it's kind of easy to understand why people can get confused. So let's think of a big circle, right? And the big circle is the superset. It encompasses all of AI. And that's going to include things like robotic automation. You see on a shop floor, these robots just moving things along. That's a component of AI. It includes expert systems, which were sort of early adopted enterprise precursors where they're very rules based driven. It also includes the subsets of machine learning. So the subset under the big circle of AI, the subset is machine learning. And machine learning has actually been adopted and in use for a number of years. Actually, some entities and sectors have been using it for decades. And it's really predicated on learning how to understand massive amounts of data and do a couple of things that are really critical for humans with that data. One is to find patterns that humans might not be able to find in that data. And if you think about cybersecurity specifically, think about how much signal we generate now in cybersecurity at a given company on a given day. So humans trying to get through all of that signal, all of that data would be very hard. Machine learning can parse through that data very quickly, find patterns that people might not be able to see, create classifications very rapidly. So machine learning is used for and has been used for a long time in cybersecurity, for example, to try and understand, is this a phish or not? Is this a spam or not? Is this malicious or not? This email that's coming into somebody's inbox. So looking for patterns, being able to create classification, and also predicting patterns in the future or classification based on the knowledge that it's been trained on. So that's classical machine learning. I've heard some people refer to it as pred AI or predictive AI. All of those are meaningful and matter, but that's that AI superset, machine learning subset. Now there's a next subset under that, and that is deep learning or neural networks. And that's a particular kind of learning that machine learning uses. And then we get to LLMs, and that drives the subset of large language models that are driven by machine learning, but are used in a generative fashion to create, instead of the predicting of, oh, I think that the weather might be a certain way, it's now using language or images to predict, but predict in a very complex, reasoning manner what might be the most best fit outcome for a question. So if the question is, could you do a SWOT analysis between two different companies? That model can then use its reasoning power and create a SWOT analysis that you asked for. So when it's predictive, but predictive in a much more complex way. So that's large language models, and they really depend on neural networks in order to drive. So AI, and we don't make it easy, right? Because it's AI, machine learning, deep learning,
And
generative AI, and LLMs. And I think that's why a lot of people get very confused because it's like, what is this? But that's really how you can think
I
about
mean,
it.
that's a
Is
great
yeah,
explanation because we'll just draw circles in our minds and then
yeah,
we always remember that.
yeah. And go on.
But
Yeah,
now, when you broke that down to me in terms of the differences, it just forced me to begin to think, what about AI systems makes good security hygiene harder than in traditional software? Because, I mean, you've just spoken about coming from AppSec. What makes securing AI so hard?
Yeah, there's a couple of things that really are making it, and it's not necessarily hard. It's that we have to learn new ways to approach securing these systems. I don't want people to get discouraged. Sometimes when people will come up and say, AI is too difficult and it's sort of magic and I'll never understand it. And I say, it's not magic, it's math. And they say, well, I'll never understand the math. We are security experts, right? That's what we do. We understand where there are threats and risks in a system, and we then figure out the controls and approaches to manage those risks. So that's what we do. We can absolutely do it here, but it does require looking at a couple of different things and thinking a little bit differently. It's a big space, but I'm going to break it down into three things that I think really will help people to understand it a little bit better. First of all, you want to weave security through the process. What's different? What's different is that process itself. Data, classically, when we in security are looking at data and creating a system or testing a system, we often just say, hey, are you using production data in that testing? Because no, don't use it, right? We're always, very careful with production data, has special protections, special segmentation. In AI, you actually need live data. You need meaningful data to train the system. So how we approach data, the data training sets, how we test with it, all of that's different. And that's one mindset shift that we as cybersecurity have to make to understand that this is now about training with data. So instead of saying don't use live data for training, it's how do we protect live data in training with models? And that's the big second one, which is models themselves. Models, machine learning models, drive generative AI. And those models are a new artifact in a lot of organizations. Many companies download models from public repositories, and public repositories like Hugging Face are fantastic. One of the reasons we've seen such amazing innovation in AI is because of public repositories and of open source. However, if you're bringing down a model from a public repository, you should be testing it. Even after you train that model before you deploy it, you should be testing it. And a lot of companies don't yet understand how to test that model. You want to test it statically to make sure that there's no malicious code in there. You want to test it dynamically before launch. And that's going to get to the third thing. So data and how we think about data and protection, models and ensuring that we're choosing the right models and we're testing them properly statically. And then before we launch them and as they go into use, there's this unique thing about models and about AI, which is another sort of pivot point that we in security have to really think about and get close to, which is that AI is non-deterministic or probabilistic. So think about when we go to test a website before we launch, right? If we see that there's a input validation error or SQL injection issue, cross-site scripting, we know what that problem is. We know how to fix it. We know every time that an attacker hits that system, it's going to have a similar response. We know how to fix it. And if it's fixed properly, it should no longer be vulnerable. Non-deterministic systems, generative AI systems, can give you a different answer every time. I mean, you probably asked a similar question to different chatbots or maybe even to the same one, and have you gotten a different answer from it or a slightly different, way of approaching that response?
Yes, I have. Down to the same prompt, even. And you may get different answers.
That's to be expected from the system because it is non-deterministic. It's generating new content for you when you ask that question. Mm-hmm. But as you can imagine, that makes testing it a little bit different. And interestingly, because you can't just test it the same way that we've been testing websites, we've been testing applications. So interestingly, one of the best ways to test a non-deterministic system is with a non-deterministic system. I think of it as sort of AI homeopathy. So actually using AI to test AI and then retraining that system, that AI, to be more resilient against the kinds of attacks that had been working on it with the prompt injection and adversarial attacks. So three big things: how we think about data, how we think and use models, and how we test them, and then just how we test AI itself because it is non-deterministic.
Oh my God, that's a fantastic way to answer that question. But I mean, we're just back from RSA conference and they happened in San Francisco, full of energy. I felt the community really bonded, coming together, solve big
Yes.
problems. But another thing I also noticed was that RSAC 2025 was buzzing about autonomous agents. Like everyone was talking about it. It was pre-painted on just about every product on the floor. So I want to ask you, what do most practitioners still misunderstand about how AI agents really operate? And why does that gap matter?
Yes, an agentic AI. I know, isn't it? It's funny. Every year at RSA, there's that, like, sort of the things that people, the emerging technology that's so exciting that we're all talking about it, all the vendors, all the people, and absolutely agree. It was agentic this year. What did people misunderstand about it? I think that it's a similar thing to what they misunderstand about AI, which is that a lot of us have gotten into this mindset that the AI is always getting smarter. The AI is smarter than people and it gets smarter all the time, as though it would just learn on this sort of linear line and be better and better and better. And that's not really how AI works. Works and can get better for the purpose that you've trained it by giving it better training or better data to train with. But it doesn't magically just get better. So when people say, well, if I'm going to buy an agent and it's going to be good this year, and that means that in a few months it's going to be better and better, it might be with the right training and the right management, and it might not be. So we can't just set and forget these agents. I saw somebody on LinkedIn refer to agents as interns with access the other day. And
You know,
and I thought that was a really clever way to put it, because these agents are only as good as what we've trained them for, and they can drift in use. So if people could understand one thing, it's that unfortunately there's still not a magic answer. Just buy an agent and it'll do everything for us. It's still going to be we as people, humans in the loop, managing and training those agents, ensuring that they're working properly. Also understanding that they're working within a system. So if any LLM or AI within the system that the agent is working within, or the agents are working within, if any one of that gives a wrong answer, you could chain that inaccuracy down the entire workflow. So agents are not yet a magic solution, and probably never,
not
since
a
we're in.
magic wand.
Yeah, yeah, yeah.
Okay, so just really doubling down on that. I know you've been a big advocate for M-BOM. Like software has S-BOMs, like software bill of materials. You've called for M-BOM, which is
Yes.
model bill of materials for
Yeah.
AI artifacts, which you've described as a new artifact you now have in enterprises and be more secure, right?
Yeah.
What does a minimum viable M-BOM look like today? And how should it mature as composability explodes?
Yeah, this is a great question. And I want to shout out specifically to Helen Oakley and the work that she's done in this space too, because she's really been leading a lot of the work around whether they're M-BOMs, ML bombs, AI bombs. We still haven't actually even figured out what they're going to be called. But the bill of materials for an AI system is going to be similar to the software bill of materials, which is to understand the quote ingredients that are used within that system. But within AI, we're going to have to look at the things that matter to AI. So, of course, you want to know the libraries and the dependencies that are in use to what you're using to deploy your AI system. But we also now want to understand the data sets, how that data was used or cleaned. Is it data that's been approved for use? Who touched that data? The models themselves, the provenance of the model, where did it come from? Who trained the model, for example? So it's going to be these other things that were the models tested. So these things that are unique to AI, we need to bring into the machine learning bill of materials, or AI bill of
Oh my
materials.
God.
But again, it's still in
It's
in its early
infancy.
stages.
Yeah.
So yeah, watch this space for more
Because
work.
I'm trying to wrap my
Sure.
head around, considering the fact that, for example, for most open source models that we have, they're not actually open source models, they're open weight models, because we don't have access to the data that that was used to train it. And so that for me is, I'm just trying to think about how an M-BOM for that is going to look with those components that we're having from the open source community come in. But I mean, that's another
Yeah,
conversation we're going to have.
exactly. Yes.
But in your
Yeah.
experience, what should a highly effective ML SecOps lifecycle look like? I want you to walk us through an ideal life cycle from data collection, which you've signposted is great, to retired models to ensure that secure by design principles are followed. So I'd
Yes.
like you to really just share a lot with that and spotlight maybe, would I say, gray areas or blind spots that a lot of people forget.
So ML SecOps, if somebody's going, what is ML SecOps? Think about the ML ops lifecycle. And then just like with DevSecOps, we infused security into the DevOps lifecycle. It's the same concept. It's think of an ML ops lifecycle and infusing security in. And security is going to start all the way at the beginning, just as that you're initially in DevSec, you're going to look at requirements. Start with that in ML, but you also need to look at scope too. Not every project needs machine learning or AI applied to it. And not every project is going to have the data that you would need to have that AI function in the way that you want it to. So first scope out what it is you want to do. Think about, do you have that data?
Mm-hmm.
And then as you get to the data, do you have the right data? Is it, you don't want to have an overfit or underfit model. You want to make sure that you have the right data, it's available, it's accessible. And that's a tricky part because you might say, yeah, just grab some data. As you probably know, if you've ever done big analytics projects, which I know you have, sometimes you can get pretty deep into the process and realize there's one component of the data that you did not capture that you really, really need to get the analysis that you want. So the data, cleaning that data, preparing it, and making sure that you've thought about privacy throughout that process. Then in the model training, obviously doing things like scanning the models, testing the models to make sure that they're purpose fit. Then as you get ready for testing them both dynamically and within the bigger system. A lot of times people will test a component. And as we look more and more at AI and at agentic AI, always remember that components may test fine in, atomically, but when they go into the system, they may have different behavior. Then, of course, as we get into deployment, we want to make sure that we're deploying our model or we're deploying our AI in an architecturally sensible way. A lot of folks are familiar with the shared responsibility model for cloud. You have less control in a SaaS environment other than over your data and perhaps authentication than you do in an IaaS environment where you can probably pick the operating systems you're going to deploy out on. You can manage your Kubernetes lifecycle over that. So how you deploy architecturally your AI really matters for security. If your AI solution is go to the free version of ChatGPT or Claude, that's going to be a very different security consideration than if you're running your own foundational models in something like an AWS Bedrock. So deployment and architecture and weaving security considerations and threat modeling and risk through that. Finally, into monitoring. As we know, models drift. AI can drift. They're non-deterministic. They could start saying things that we don't expect them to or are not accurate for the purpose that they've been built. So monitoring is absolutely critical, that these systems are behaving in the way that they were purpose-built to behave. They're doing what you as the deployment team want them to do. And if they don't, you're going to have to bring them back in for retraining. If they do, but they hit the end of their life cycle, obviously you're going to want to take them out of the life cycle, make sure that they've been torn down and removed and cleared out so that nobody else can access them. And throughout that whole thing, you're going to be looking at some really standard kinds of security applications like zero trust, making sure the models are accessible only to the right people, least privilege for access to data, access to APIs. All of these things start to work into the ML SecOps lifecycle.
Oh my God. From your response, I have like two questions just jabbing at my mind. The first one is, what happens if your model is overfed with data? And then my second question is around runtime visibility, because that's a big issue now. We haven't, I say we're just struggling as an industry to really have that runtime visibility into what's happening, given what you've also just said that, things can change. You may have tested statically, dynamically, but things can happen in runtime. I wanted to speak to us more about that.
Okay, so yeah, at runtime, I mean it's exactly what you're talking about. Is that we need to use tools, and there are different tools that are emerging. Some tools are hooking the kernel using eBPF to get visibility into the inputs and the outputs to and from the LLM or to and from the AI system. Between the agents even. There are some folks that are using a layer, just a proxy itself, to sit between those points between the input, and it might be coming from a human, it might be coming from another LLM, might be coming from an agent, but sitting as a layer between there to look at the input, and then capturing and parsing the output that comes out from the model itself. So a lot of different ways. There are some folks are looking at sort of like a tap or span port concept of being able to just look at what goes back and forth. So there's no latency, but they're able to forensically later on, if something did go out of whack forensically, they have that full audit trail of the inputs and the outputs.
My other question was around what happens when you overfeed your AI. I mean, it's easy to say, oh, underfeeding hallucinations, right? But what happens when you overfeed it? What's the risk?
Oh, I see. Yeah. So if you've overfit, and this is very much common in traditional AI, if you overfit a model, it gets really, really, really good at predicting when it knows the data, because it's really good at seeing all the anomalies in that one set that it was trained on. But it gets overfit. It's too good just to that set of data. So when it gets new data, it actually doesn't make the intelligence analytics that you'd want it to do with newer data. It sort of doesn't have that flexibility. It's too tightly trained to the training data.
I see. I mean, I missed your talk at RSA. I still have myself to blame, but maybe I'm going to have to find the recording and watch it. But I just wanted to ask, some questions from that session because I was probably looking forward to that.
Sure.
What is shadow AI, and what are some of the ideas you shared at RSA for tackling this, especially in a bring your own AI era that we just stepped into? And I'd like to pull a reference to cloud, because we've stepped into something that mirrors the early days of shadow cloud, for example. So I want to ask what big ideas you've shared at RSA, and you can share with us as well. And also ask which governance lever has proven most effective to tackle this shadow AI issue. Is it policy, discovery tooling, or cultural incentives?
Yeah. Okay. There's a lot to unpack there. First of all, I do want to call out that particular talk at RSA was a panel. And so I had three very smart folks on the panel with me. So there were a lot of different ideas. And actually, I think we're going to be putting out a little note on LinkedIn with sort of like our interested takeaways from that. But shadow AI itself is very interesting. And you are completely agree with you. It's very similar, at least in the Gen AI space, to what happened with cloud. Because right now, what a lot of people are focusing on with shadow AI is, oh my gosh, I only want people to use Gemini, for example, or I only want them to use Microsoft Copilot, but they're running off and they're using Perplexity and they're using Claude. And how do I stop them and help me, make sure that people are using AI within my organization the way that we want them to do it. So in that case, it is a little bit similar to the shadow cloud, where it's a matter of monitoring the traffic that's going in and out of your organization. And if you see somebody going out to an AI an AI SaaS that you did not approve at your company, gently saying to them, hey, that's not the AI we're using. This is the AI that we're using. So redirecting them to use an AI that's approved by the company. But we also talked about, and this was something that I really had wanted to draw out in this panel, so I was glad that we got to discuss this too, that there's another component of shadow AI that people have not looked at as closely, which is the predictive machine learning AI that's been in use in some organizations for decades, that has been cordoned off. I think of it a little bit like OT, operational technology, which was just running kind of in its own space for many, many years, and availability was most important. And you didn't bring in some of the other security that, like monitoring tools that we were familiar with in IT, because OT was very much about keeping availability going. That's been the same with predictive AI and machine learning, is that those groups were often in a segmented portion of the company, those machine learning engineers, data scientists doing their work in a segmented way. But now, as more of that work is kind of being brought out of the shadows, it's really important that we infuse security into those systems that were protected with isolation earlier. But now, as with IT and OT kind of converging, as we bring predictive AI more into the spotlight, and that work is going on in more parts of the organization, we also need to bring that out of the shadows too, into the light of governance. That's how I think of it. How do we do this? Yeah, that's a great question. I strongly believe that the best way to do this is with empathy and understanding, and with an eye towards how do we keep the business doing what it needs to do. So with your predictive AI folks, your traditional machine learning data scientists, sit down with them, understand what they're doing, what they have done, what they need to do going forward so that you can help them create better programs to ensure that there's security wrapped around all of that great work that they're doing. With the Gen AI, right, the one that we're all worried about, everybody's like running off and getting their own models, downloading Llama from Hugging Face. And that, again, is about having conversations with your company. You might be surprised. You've probably got developers who are vibe coding now with AI. You've got marketing who are building, customer bots with AI, that they're using AI to start parsing through and figure out, better and more effective ways for lead generation or customizing things for customers. It's everywhere. Gen AI adoption is all around organizations right now. Understand which teams are using it, how they're using it, how that's going to help them do their job better. And then once you have all that information, you can start to build the controls that will enable them to leverage the benefits of AI, but not put the company at additional risk.
I love that response. And just really piggybacking on your background in AppSec, right? And applying that to now on AI and ML, which standard AppSec and LLM defenses simply don't apply to agents or multimodal systems. You've talked about the mindset shift, for example. So is there something else we should be taking note of that doesn't apply here?
Yeah, I think because multimodal or multi-agent systems very often use chained LLMs or multiple LLMs, a lot of what applies to LLMs goes in there. But now when you get into agentic, you've got that complication of things being chained together and interacting. So again, a failure in one LLM within that system in an early part of the chain could actually mean that the entire process gets thrown off because that one output was not accurate. For AppSec to LLM multimodal AI, I think just truly the biggest difference are those things I had mentioned before. We have to think about data differently, and we absolutely have to understand that these are non-deterministic. So how we train and how we test, we've got to have a mind shift.
That's so important to note. But I know you've dealt with a range of teams, right? And this question would most likely help a team just starting off. So my question is, for teams just starting ML SecOps, which early indicators prove that they're investing their efforts where it counts the most?
I think that they're actually asking the questions really matters. Just even saying, "Hey, we'd like to bring ML SecOps in." I think that's an indicator that security is now a consideration in a way that it wasn't before. So asking the question, I know that sounds kind of obvious, but it really is very meaningful. The other two, big points or actually, it's just the point of, do they understand the importance of test, whether it's testing the model statically, dynamically before launch, or monitoring at the runtime? Are they starting to look at test and observation for what they're doing? Because if they're not testing these systems to ensure that they're resilient to attack, in addition to the fact that they're operating as expected, then they may be missing a lot out. So I think those are the big ones. Are they starting to look at, have we tested our models? Are we testing them before we use them? Are we testing them before we deploy them? And are we watching them and monitoring them at runtime?
Awesome. So really just going back to, again, with startups, in your opinion, among AI native startups that you advise, what security hurdle consumes the most oxygen?
Yeah, it's interesting because you're absolutely right. I am talking to, fully AI native story. It's all vibe code, it's all agentic. It's a very different space. But I think that their security hurdles are actually fairly consistent with what we've seen before. I mean, obviously there's almost like there's the hurdle or the hard one, knowledge of, just because we can vibe code doesn't mean that we can forget all of what we know about secure software development. You still have to do a lot of that work. The big hurdle is not understanding the market, not understanding what needs to get done, and then overestimating how quickly AI is going to get there. So I think it's some fairly standard, founder kind of pain that's going on, which is making sure that you've identified the right pain that people are in, and also ensuring that you're building it with the correct tools. Because AI has this sort of, it's a little, tantalizing to think, oh, I can just, and I was even reading about that early on. People were like, I'm just going to use ChatGPT and create a whole company and make, a unicorn tomorrow. And it's like, that's not really how the technology works. And you also, to have a unicorn, you have to make sure that you understand what the problem is that people really, what their pain point is that they need to solve.
Perfect. And I mean, I'll be preaching to the choir when I speak about training data sets being poisoned. I mean, you just started off your chat with talking about the importance of even testing this models, that people can just grab off places like Hugging Face. But I want to ask, what practical controls can resource constrained teams deploy to detect poison training sets?
Yeah. So obviously, if you have your own training set, if you have control over the training set, right, that's going to be the best way that you're going to know and detect access to and from the training set itself. That's going to, access control around who can see the data, who can touch the data. If you've got a model and you don't know what data it was tested on, it was trained on, then some of the ways you can figure out if there's something in there that you don't want is actually by doing that dynamic testing. So asking it a lot of questions, querying it for responses and seeing, are these responses accurate, or are these responses starting to indicate that there's something that is not to be expected? Also doing static analysis to look for if somebody's sort of burned like a neural architectural backdoor into the system, and that would trigger that it has a certain response after it's gotten a preset prompt. It has a specific response. That would also be an indicator that you've got, that when it was being trained, it was being trained in a way that wasn't as expected for the company.
Awesome. So I've been touching on Hugging Face, throughout this chat, and you've spoken about how the open source community has really helped with innovation around AI. And in April, the news broke about Protect AI's partnership with Hugging Face. I honestly heaved a huge sigh of relief and was very excited for very obvious reasons, right? And it's telling why I was very excited. I read on your website that Protect AI's Guardian scanners have scanned 4.4 million model versions and flagged over 350K issues. What trend most surprised you, and how should security teams translate that into an import checklist, for example?
Yeah, it's funny. I guess that the most surprising thing ultimately wasn't that surprising, which is that attackers really are very good at using old techniques in a new space. We moved to the cloud and we saw account takeover and privilege escalation kind of carry over from on-prem right into the cloud. So with Hugging Face and with the models, what are attackers trying to do in models? Typo squatting is actually one. So just as we saw people, typo squatting with malicious websites that would have drive-by downloads on it, people are typo squatting models. So, Llama 3 is a very, very well-known model. It comes from Meta, but it's called Llama. And there were typo squatting folks who were out there with, saying, oh, it's Meta Llama, right? So, trying to get people to download their risky model by naming it something that was as actually a well-known and desired model. Dependency attack chains. So exploiting a vulnerability in a library that's used by an ML flow or used by the workstation. So trying to get in that way. Inserting malcode. We saw it all the way back in steganography, even with images, right? We've seen malcode embedded in Word documents, for example, and they are embedded in models themselves too. And when the model is then deployed and run within the workflow, it can lead to, serious risks as that malcode, that Python code, for example, is executed, even things like, account takeover, takeover of the system itself, access to very highly sensitive data, exfiltration of that data. We've seen things like a get adder, an attribute saying, go out to an S3 bucket, download this executable, and then run the executable. So acting like, dropper malware.
Wow.
And then those neural backdoors that I had mentioned too, again, burning in a sequence that can be triggered with the right prompt. So a lot of different attacks for people that are hearing like, wait, dependency attack chain and, malcode insertion. I know it isn't entirely new. It's just this is within a new artifact and we need new tools to identify these risks and to be able to report out on them. And one of the nice things with Hugging Face now is that you can see our rating of a model before you down it because we've pre-scanned it. There are some other tools too that Hugging Face is using there. So it's kind of like a virus total kind of thing. You can see different scans and different companies that have scanned those models saying, this is the risk or not the risk. So it kind of gives folks that are downloading those models a little bit of a,
I love that. I
warning.
love that
Yeah.
collaboration. It's
Yeah.
what we've been waiting for.
Yes.
And
Yes.
the way you've just described it so fluidly, it's so beautiful to hear that this has happened. And again, you can tell I've been spending time on the website. I read your vulnerability assessment report that showed that GPT 4.1 mini earned the highest risk score among the three models after the latest update that was done. It was vulnerable to prompt injection at a whopping 53.2% success rate and highly susceptible to evasion techniques. So I want you to please tell us more about how these findings were made and possibly share more insights from that report.
Yeah, we made those findings with this tool that we have. It's called Recon, and Recon has an attack library that we've learned over time, both from our own research, from research that we've seen that we've incorporated from others, but basically the general community coming together and saying these are ways that LLMs are jailbroken or prompt injection works. We also use AI to test AI, because of that non-deterministic piece. AI is really one of the best ways to test it. So prompt injection or jailbreaks, these are just ways to manipulate an LLM into ignoring its developer safeguards. So the developer might say, never give out information about how to build a bomb. How to build a bomb is a common one, or never generate malcode, for example. They're trained not to provide this dangerous content. A prompt injection attack or a jailbreak is a way to get the LLM, the Gen AI, to one of those models, to respond with something that it shouldn't. So that's what that testing was looking at. And that's what the nano was actually the most susceptible to, was that it would actually respond with something that was potentially dangerous content. So they found that, about 50% of the time. Another attack that we found had pretty great success is sort of orthogonal to a prompt injection attack, which is adversarial suffix attack. So you add a malicious suffix to a prompt, and then that's designed to have the LLM, again, ignore the guardrails and return the malicious or otherwise undesirable responses. So yeah, I mean, these are ways that these tools, the guardrails are built in, but folks are looking at ways to get around those guardrails, and our testing showed that that these systems, as with many, even with these very well trained available models, that they still are susceptible to prompt injection and to jailbreak.
Yeah, with all of what you just shared with me, what I'm thinking about is downstream impact. And just really going back into this conversation around GPT 4.1 mini being a foundational model that's used in countless AI applications across enterprises and in some cases consumer focused AI applications. What do you think is the downstream impact that we might see on agentic systems, on agentic systems relying on that model? And it's important for us to mention this because, I mean, considering the fact that its enhanced code writing capabilities is expected to find great adoption in building agentic systems. So we are going to see that this has a knock-on effect. What would that look like?
We both said a number of times is that any time that a model returns an undesired or inaccurate response, there's a risk. But let's say that you're trying to write an email, or you're trying to write a press release or something, a blog post with the help of a Gen AI. The Gen AI is going to respond. You say, I want to write a blog and it's going to cover this, right? And the Gen AI responds, and you, the human in the loop, right? You then look at it because this is going to be your blog, and you parse it to say, is this right? Is this not right? Do I want to publish this? And it's probably a great starting point, but then you, the human, are the one that really makes that final decision. Is this going to be something that I then move to the next phase, i.e. publish? In agentic systems, very often you have software and other AI who are making that decision. So if we go back to generating an email, you're going to read that, or let's go back to the blog, right? You would proof the blog. Let's say that you want to have a fully agentic system. You put the prompt in and say, I want to have this blog post go out, and then that blog gets written. It gets formatted to go up on the website. It gets published on the website, and this is all different agents are now enabling this and taking autonomous action to make this happen. And then it goes up on the website, and you have an agent that then, I was going to say tweets, I don't know what we say now, X's about it, and one that puts on LinkedIn, so tells all your socials, hey, here's this great blog post I have. So now if we take the human out of the loop, let's go back early in that chain, and that blog post, it wasn't quite right. It had something that maybe you wouldn't feel comfortable publishing, for example. But the chain is now running. So that this not quite right blog post comes out, it gets formatted. Maybe there's an error in the formatting, or maybe the formatting looks beautiful. It gets published, but it's still got that not right thing in it. And then perhaps the agent that is now talking about it on the socials just picks that exact thing to highlight, or maybe that was used as the headline. So now there's this piece of this blog that you don't really want in there, but the system is now, it's not just publishing it, it's also highlighting this to your socials. So that's where, as we look in the chain, we talk about inaccuracies being sort of amplified. That's what it means, is that when we take humans out of the loop and they stop checking, if a system does not, if it hallucinates, it outputs something that is not accurate within that chain, you can see how it can then get amplified and connected throughout the process.
Yeah, just so spot on. But let's switch gears a bit. I'd like us to discuss red teaming beyond the theatrics, right? How do you structure AI red team engagement so findings translate to system fixes rather than prompt leakage, show and tell?
Yeah, I love the point that, you talk about like red team theatrics. I was actually at a luncheon recently with some current former military experts, and they were saying that they look at the term offensive of operations, and they think of it very differently, because it's very distinct in military offensive ops than what
Yes.
we
And I
think
think
of, right?
I
As
think a lot of our terms are taken from military and medical practice as well.
Yeah. Yes. So a cyber red team is a little different, obviously, than what would happen in the military. But you make an excellent point, which is that, it's all about find the problem, right? And red teams are really good at finding the problem. But when you take security holistically, right, you look at the full purple, right? The blue needs to defend. We need to understand, thank you for finding the problem. How do we actually go about and fix it? So I think that's where, where the rubber really hits the road, which is talking about like, tests that will improve the functionality, making sure that they're giving us the kind of information that we really need to make that LLM more effective, and then focusing on where those guardrails, or where the prompt injection, worked, where the guardrails failed, where the prompt injection worked, being able to take that information and then feed it back either into the training so that you can be stronger and more robust with the training next time, also to feed it into anything that you're using to monitor, like a proxy or a firewall, to make sure that you now that you know where things break, that you can put a deeper, closer eye on it. The other thing that I think is really important is that as you're red teaming, you may find out that one system or one LLM or one model isn't right for that purpose. Sometimes we sort of think of AI as like this big, it's the big circle, it's the big thing, it's monolithic. But very often systems are made up of multiple different models. So you may find that in testing, one model might not be as effective at that task as another specific model. When I was at Microsoft, for example, one thing that we were doing is that we had multiple models on the endpoint and models in the cloud. And the models on the endpoint were meant to be very fast, very lightweight, to be able to look for certain indicators of badness on that system. But then there were other models in the cloud that had a lot more compute and had a lot more depth to what they were doing. And that was to do different levels of scanning and evaluation. So keeping that in mind, that, with the red teaming, making sure that you're taking what they learned, you're infusing it back into the system, whether it's in monitoring or in test. But also you may find in your red teaming that some models are better for some purposes than others.
That's a very valid point there. But I also want to follow that up with asking that, with the increased use of large language models for both offense and defense, what concrete steps should organizations take today to brace for AI powered offensive tooling?
There's one AI version, and maybe it has AI, maybe it doesn't. So the AI part is that we're really going to have to fight AI with AI. We've seen this for years, this bit of a Cold War between the attackers and the defenders, looking at tools that understand how to use AI to defend against AI attacks. When we see that speed and velocity of attack with AI, being ensured that we've got the kinds of systems that can identify them very, very quickly. The other thing, which is a little bit less AI, although I've seen AI come into this space too, is making sure that we put process in place that is AI aware? Are your incident response plans AI ready, right? AI attack ready? Are you looking in the right place with your incident response plans? Are you getting the right signal? Do you understand where things can go wrong? So making sure you've built that in, making sure that you've trained your users on AI powered kinds of social engineering, because we're seeing a lot of that. Now it's much easier to create a voice that sounds like somebody. It's much easier to create a video. It used to be you would say, well, if you have a conversation with somebody on the phone, then that's telling you that person. So you got an email that said, or a text that said you needed to transfer $3 million. Just make sure that you talk to them on the phone. But attackers now can actually emulate people's voices, and there have been some attacks with AI generated voices. So making sure that people understand that some of what we used to think, well, that's if it's a video of that person, we know it's okay, that they need to go a little bit deeper and to actually be on more of an alert for these AI driven social engineering attacks, because those are becoming more common, both in modality in terms of, is it like video and language, but also in terms of depth of knowledge, because it's fairly easy now for folks to dox a pretty good amount of data about organizations and about the people that work there quickly with AI. People expect that because, like, if somebody, I use this example all the time, if somebody comes up to me and says, hey, Diana, I went to Boston College too, and I just wanted to know how your dogs, Nick and Nora, are doing, would I assume that I knew them? Not at all. They just told me some very public data, so it doesn't mean
And
they know me.
the dogs have been strutting throughout this.
I know they're kind of a little famous now. So yeah, so knowing Nick and Nora does not mean that you know anything about me.
Yeah. Awesome. So really just going back to the fact that we've established that AI systems are probabilistic, right? Where are legacy security tools failing probabilistic systems, and what new capability do you wish a vendor would tackle tomorrow?
Yeah, I think, I mean, we've talked a lot about the testing and all that, so I won't go back into that. But something else and I'm actually really kind of excited about AI here, which is in DLP, or data leak prevention, or data leak protection. Because DLP, we had huge hopes like 10, 15 years ago when DLP was hitting the horizon. We had really huge hopes that this was going to help us so much with data going across sort of the blood brain barrier. Is it going outside of my organization? And then as we actually started to implement it, we realized that these rules were very brittle. There was this hope of like, oh, resume, we're going to block resume, and anybody who's trying to send their resume out, we're going to know. And then it was like, that didn't work, because resume is the thing, and that's a word that people use all the time. So a lot of DLP really focuses on these very easy to pattern match kinds of pieces of data, like, as a credit card data or social security number, for example. But with Gen AI, which nice is that Gen AI, because of context, because of natural language, it's easier now to be able to catch some of those things that people were trying to obfuscate. So somebody's saying, I'm looking for a new job. Maybe what you were doing was you were just looking for an attachment that said CV or resume on it, and then maybe you caught some attachments that had the word resume in it. But now with Gen AI and with NLP, natural language processing, you can catch things like if somebody's saying, hey, I'm interested in that thing you got open, here are my work deets, right? And a Gen AI would be able to go, hey, that's somebody who's actually having a conversation about trying to leave this company. So I really love where we can go with DLP. And I know that there are a lot of companies that are doing more and more with AI driven DLP. So I'm pretty excited, as far as like vendors and what's changing. That's one that I'm very excited for.
Awesome. And let's just also talk about regulation a bit. We know regulation always plays catch up. So if you could insert one clause into the EU AI Act or NIST AI RMF to really fast track alignment with technical realities which you know on ground, what would that clause be?
Well, I have a huge respect for the work that's going on, especially EU, NIST, AI, RMF. I'd like to see, so huge respect. No one size fits all. And I'd like to see, and I know the EU does talk about sort of the risk levels of what's being used. I think that's fantastic. And I'd like to see even more focus on the security frameworks within that shared responsibility model for AI, because it is a different model if you're using a public version of a foundation model, if you're using one within your organization for example, like a Copilot or a Gemini that may be embedded in your workspace, or if you're running one on your own. So I think really starting to talk about the different use cases for AI and the different architectural deployment models so that folks can understand that AI just isn't sort of like, it's like we secure AI this way. It's that we're securing the very specific deployment and use cases of the AI so that we need to make sure that we've done the right security risk management for that deployment and use case.
So let's go back to your role as a CISO. Many people imagine the CISO role as high pressure and highly strategic. If I shadowed you for a day at Protect AI, what kinds of decisions and challenges would we see you navigate? And with so much happening in AI security, what does a normal day even look like for you?
Yeah, I don't think there is a normal day. I can tell you that some of the challenges and I don't see them as challenges. I mean, it's actually been like the fun of the process of being able to be the CISO here, which is that I was employee number 11 2 years ago at the company. We have over 125 people. We have been through a Series A, a Series B. We've acquired 3 companies in 3 different countries. And it's just been this incredible, this like, rocket of growth. And so the big challenge for me is twofold. One is, how do I keep this dynamic cloud AI driven company and engineering driven organization? How do I do what's responsible for the company and for our customers while enabling this rocket growth? So that's a big one, is always balancing, what's the right thing? Because obviously you can't have too much security. You can't block people from accomplishing what they need to, but you must protect data at the right level in order to protect the company and the customer. So that's a big one, is balancing that.
Balancing acts.
Yeah, yeah. The other thing is that we were a small team when I started. We've grown the security function, obviously, as the company's grown, but we have a lot. A lot of times the CISO is focused very much on the information security part. Me and my team, we have corporate security, we have security engineering and AppSec, we have physical security, we have help desk, we have third-party risk management, we have compliance, we have a lot of stuff. So just making sure that I'm looking not just at what the company needs today, but trying to think about and understand what the needs and the growth. And so there's a lot of, talking to the CEO, talking to our president, understanding where are we today, where are we going to be in 6 months, where are we going to be in a year, to make sure that I'm building a program that will be ready to take on those challenges when they come.
Awesome. And Darren, I have been privileged to know you for, say, 2 years or thereabout. And I know you're such an amazing person. But I want them to also get to know one thing about you that's about, let's say, about your personality. I would say personality trait of yours that has really carried you through the years, has helped you navigate both the highs and the lows of your career. And how could that trait, for example, serve as an advice to someone who is just starting out?
I think it's sort of two sides. The first one is a never-ending curiosity, because things change. I was talking about stuff back in the 1970s. As you can imagine, what I learned then does not really. Actually, there's some things that have carried, but a lot of what I learned, I had to, doesn't apply, right? You have to keep learning. So having that curiosity, continuing to learn, continuing to be interested really matters, because the technology is going to continue to change and grow, and you've got to stay with it. What you learned yesterday may not work tomorrow. So that curiosity, but with that understanding that you don't know everything. I don't know. Not you. You probably know everything. I don't mean that. I mean, like, me, I don't know everything. The
Yeah.
way I get smarter is by talking to other smart people, learning from other smart people, reading their research. So actually, making sure that you've cultivated the people that you know and you trust, staying in communication with them, being part of this big, wonderful network and community that we have, so that your curiosity, as it's growing, you also have places to go to say, hey, I want to read more about this. I want to learn about this, knowing who you can ask. They might know, or they know a great reference or somebody that they can refer you to. So having that curiosity to learn knowledge, but also humility and networking to keep engaging in that knowledge.
Awesome. So, although curiosity killed the cat, curiosity is actually helpful for you. Awesome. So just to wrap this whole conversation up really nicely, I'd like you to paint the 2028 threat landscape picture for us. What AI and ML security risk do you believe is still hiding in plain sight, waiting to surprise us next?
Yeah, I'm not sure if it's exactly hiding in plain sight, but I think 3 years is a long time. But I think what we're going to have now is, if you've noticed over, Gartner, right? They have like the hype cycle, right? And it's like there's this, like, everybody gets really excited, and then you go to the trough of despair. I wouldn't call it the trough of despair, but I think that the risk that's coming up is organizations maybe overestimating what AI and ML can do. So I think having to kind of reground and understand really where it can help us with security, and being able to apply it in a way that's going to be the most effective for organizations as they grow. So I think it's this there's been a little bit of maybe overhype, but really just hopeful. I see it as just really exuberance, optimistic exuberance. So I think that the risk here is that companies need to reground, understand what they can do with AI, and make sure that they do build security in. Because, as you know, with any technology, there's always this big excitement to just go out and grab all the opportunity that we can. And I understand that. I get excited too, but we will need to make sure that security is built in, because if just opportunity without risk being managed is often something that ends up like that very first time, when I had my big beautiful network that I built and somebody got onto it, right? So we always need to build security in, to make sure that we are getting the best out of the technologies that we're adopting.
So,
And that
Diana,
includes
where I'm
AI.
from, we describe that as coming out to touch the grass.
Yes. Yes.
We all need to come out and touch grass with our feet.
I love it. No, you're absolutely right. We do. We need to touch
Yeah,
grass on
so
AI. Yeah.
thank
Yeah.
you so much, Diana, for coming on and having this conversation. I stretched our time by 10 minutes, but you were so kind and generous to just stay on. I am so excited about this conversation, and I can't wait for everyone to get to watch this or read it in the magazine. Thank you for coming on AI Cyber Magazine.
Thank you so much, Confidence.